Hello. Well, good afternoon, and welcome to my presentation, which is going to be upgrading an Exadata to 18C. It's going to be a little bit of an explanation of what is an Exadata for those of you who don't know or don't understand it well, and then all of the issues that we have faced when we try to upgrade an Exadata software version from 12 to 18 and RDBMS to 11 to 18 as well. I come from a company called Pythian. We're a 400 and a little bit more persons across the world, and this is a Canada-based company. This is a little bit of all of the infrastructure and services that we do. Mostly, and myself, I'm focused on databases, but my company, a lot right now, obviously, it's cloud that we're also going into. Hopefully, by the end of the presentation, everybody's happy and everybody will be here asking a lot of questions. So hope you enjoy my presentation. Where do I come from? I used to have a slide where I used to have a lot of things that I covered and that all of the world that I traveled. But I think it's much better if you just go to my webpage, reneeace.com, and you'll find this presentation and the blogging that I do, and a lot of personal stuff as well that I do. And I tweet a lot, and this is my Twitter handle. And this is a hashtag for this conference if there's anything that you want to tweet there. So for those of you who are getting into what is an Exadata, well, an Exadata is a machine designed by Oracle, right? This came from when Oracle bought Sun, and it's basically just Exadata storage software and database software all put into a machine, highly redundant with a low latency InfiniBand. Now, physically, the Exadata looks a little bit like this, and it's the storage nodes, the database nodes, and all of the other network components in the ILOM, the KM, and the InfiniBand leaf switches. Now, the Exadata has two power distribution units in the back, and it also comes with the latest, which is the X8 spare parts. So these are some of the spare parts that the X8 has. Now, there are different mount options that you can do with an Exadata. It starts with an 8, and then it becomes an 8 elastic. And from there, you can go from quarter, half, and full. Now, an 8 elastic means that you can have 2 database servers, and you can have 3 or more Exadata software cells. Now, this is a little bit of the generational advances that the Exadata has had since when it started, right? So it started with 168 terabytes of data, and we are currently in the X9 at 3.0 petabytes of storage. So as you can see, we have grown a lot. Storage, it started with 0, and currently we have 920 terabytes, and similar with the CPU and with the memory, right? So the advancements that we had just in 10 years from the Exadata are very exponential. Now, to give you a little bit of how inside it looks, well, basically the database nodes is everything that you already manage with non-Exadata hardware, right? Which is the grid infrastructure, the database rack, And all of this is with Linux or Solaris operating systems, and just basic commands that we already know. So if you have never managed an Exadata, this is very familiar. Nothing out of the ordinary will come into play. Now, when we're starting to manage an Exadata, this is what is a little bit different, because this is what makes an Exadata the heart of the Exadata, which is the Exadata storage servers software. It has PCI flash cards. Unlike the previous, this is managed only with Linux operating system. This is not managed with Solaris. It has also the rotating magnetic disks, and we have a little bit different commands as well to manage the storage cells, which is the CLCLI, DCLI, and obviously, and as well, Linux operating system commands. Now, when we're talking about the latest Exadata storage software, which is 19.1 or 19.3, one of the biggest change it comes that it now manages Oracle Linux. Up until 18, we were talking about Oracle Linux 6. Now we're talking about Oracle Linux 7. And this is a very big change when you're doing an upgrade, right? Because the operating system dependencies can and will change from one to the other. Similar, it still manages 11G databases, 12C, 18C, and up until 18C. Now, one of the very good things that it has is the automated cloud scale performance monitoring. Now, what Oracle has done, similar to other products that it currently has, is that it's now using machine learning to monitor and to alert things that are going on within the storage cell and as well within the database servers. So this is very, very cool. And the other thing that it introduces is that we can now use REST services to control our Exadata. So this is some of the things that you can now in your own site or within your own internal company can manage the access control for an Exadata. So these are some of the changes that come with the storage software 19.1. Similar to previous Exadatas, this is how it supports. So basically, you have different versions. Currently, 19.3 is the latest one that was released, and it sends the information to the cell server. It offloads to the cell server all of the how do I say it, the database loads. It offloads it. All of the I/O sends it, and this is where the smart scans are managed. So this is a little bit of how it works, but I'm not going to go deep into this, right? Now, we came here to talk about patches, right? So this is a little bit of the different type of patches that we manage within our Exadata. So we have the storage server software, the database server, the InfiniBand switch, and some additional components. Now, this is some of the recommendations that Oracle has on how you're gonna, you can do your patches for your Exadata. Now, this doesn't mean that you have to follow it, but this is best practice to have. So it manages rolling and non-rolling. So it also depends on how much outage time you can have within your company. And it also manages if it's a quarterly patch or if it's a semester patch. Normally, these, the InfiniBand and these additional components, they tend to have very few patches throughout its lifetime within an Exadata. Normally, it's 4 within a lifetime of an Exadata versus a database server. It's every quarter that's normally changing. Now, what are our patching tools that we have? For the database and the grid infrastructure, it's the standard tools that we know how to manage. It's OPatch, the database universal appliance or component, the UEI, and Enterprise Manager. For the Exadata database server, we now have the Patch Manager and DB Node updates, which basically Patch Manager, what it does is it calls the DB Node updates for all of the database servers within our Exadata. And for the storage server and InfiniBand, we manage with Patch Manager. Now, the software maintenance, and as I was mentioning, this is some of the suggested schedules, right? So it's very rare that you're changing the grid infrastructure release as common as you can change the database, right? So just be very mindful of how you will change and how you will apply all of your patches and upgrades within your Exadata. This is some of the recommendations as well that my company has and that Oracle as well has. Now, one of the very important things when you're doing an Exadata upgrade is to use ExaCheck. Why is it very important? Because this is where you'll find errors that will impact you when you're doing your upgrade. So, and I'll talk a little bit more in the code that I have, is that we found when we were going to be doing our production upgrade that during the ExaCheck that there was a mismatch between the hardware information and the profile information that the Exadata had. So it actually, from a junior DBA, he tried to run the upgrade and it failed, and there was a big outage. Luckily, it was in the development environment, so there wasn't a production impact. But doing an ExaCheck and not correcting what it comes out, and especially as critical, will have a very big impact during your upgrade and your patches of an Exadata. This is some of the checks that the health check does. And I won't go much into it. Just get very familiar on how it looks. And take a look at this MOS document, 757552.1. And it has the latest best practices. So take a look at that before you're going to start an Exadata upgrade. It's going to have the best information that is out there. This is a little bit of how it looks, the critical issues and the installed versions, right? So the critical issues is what you always want to have your main focus at, because I can guarantee that an upgrade or a patch will normally fail if these are not fixed before doing it. If you are using as well Oracle Platinum services, they will ask you to resolve the critical issues as well before they do the patching. So this is some of the operational practices, and basically it's just the issue resolution, the version support. Be mindful that the version that you currently have for your Exadata and your RDBMS is supported. take for example 11.204 as of July of this year is no longer supported, right? So you won't find patches without extended support. So just be very mindful of the version that you're managing. What we normally do is we refine the patching plan. We do an action plan of all of the steps that we're going to be executing. We run a Nexus check, we patch, and we test. And we repeat the cycle from development to testing and all the way when we get to production. So how do we patch it? So we use the patch manager, and this is how we patch the storage server. Patch manager sells patch pre-check, prerequisites, and we can tell it if it's a rolling and non-rolling fashion, right? Now, when it's a rolling fashion, it's going to use ASM disk resync, right? So be very mindful of that. But the very good thing is that there's not going to be a downtime when you're doing or you're executing your upgrade for this. In a non-rolling, all cells will shut down, and it's going to be a faster upgrade because it normally takes about 90 minutes per cell, per storage server. So it's only going to take 90 minutes. If you have 3, then it becomes 270 minutes, and so on, right? So it depends on the number of storage cells that you're going to have. So that's why right here it all depends on the number of storage cells that your Exadata has. And this is a little bit of how it looks, right? For example, I have a customer that even though they couldn't afford a big downtime, like 90 minutes, the main problem that they were having was that they had very little space within the storage server. So they were very afraid that if it took longer or if there was an issue during the upgrade and it took longer than the resync would take, they would have data loss within their environment, right? So it's something to always take into account on what are the impact that it can have. It might be data loss. It might not even be the service level agreement into the decision of how you're going to be patching, if it's going to be in non-rolling or rolling mode. So now we're going to get a little bit into the issues that I faced with several clients when going from an Exadata 12 to an Exadata 18. So currently, one of my teammates, they have in this URL, he manages a lot of scripts that are very helpful and that I really recommend that you download. Rack status, Exaversions, and LS patches for all of the information that you need to gather for your prerequisites when you're going to be upgrading or updating your Exadata. So I really recommend that you use all of this. And as I talked, Patch Manager and DB Node Update, right? So these are two of the scripts that Oracle uses. DB Node Update is a shell script that patches every database server individually. And Patch Manager is an orchestration tool, so you can see it as something that is wrapped and that calls the DB Node Update. So In the past, we were only using dbnode update, but later on, Patch Manager was introduced. So this is one of the very first things that come into play. What I've seen with clients is that they have their own packages installed within the Exadata. And Oracle really and highly recommend that you don't do custom packages within the Exadata. Normally, when you run the Patch Manager, the pre-checks, this is a little bit of the information that you'll find if you have updated it with that or outside of Patch Manager, or any dependencies that it currently has, and that it goes and impacts your Exadata. One of the things when you're running the pre-check is that Patch Manager won't take care of your custom RPMs. So you have to remove your custom RPMs before you do an upgrade. You do the upgrade, and if you still need those RPMs, you need to install it for the newer version or the kernel that it was updated to. Patch Manager, and it's something that you have to be very mindful. It will remove system RPMs when it has failed dependencies. So if you installed a custom RPM and it cost the system RPM to have a failed dependency, Patch Manager will remove them when you're running a prerequisite. So Oracle highly recommends that you execute the prerequisites within a maintenance window. So one of the problems is that it can cause an outage, even though it's a prerequisite check. You're not doing the actual upgrade at that point in time. So the very first issue that we faced was that the HCA firmware was not matching the profile, right? So when it came up during the ExaCheck, and you can run this command right here, check hardware profile, and it's telling us right here that the hardware and firmware didn't match the profile. So what we did to fix it was, in our case, we stopped the grid infrastructure and databases before. We ran the check hardware FW profile. We ran the check hardware with a -u command and this parameter, and this will reboot the server. So you need a maintenance window for this. Then you need to run the same command, but with an action update for the profile. And the component that you're going to be updating, and in this case was the InfiniBand HCA. Once we did that, we brought up the grid infrastructure and the databases, and we checked and verified that the firmware version was now matching, and it was. So the next error that we faced was during the upgrade of the grid infrastructure, it was failing due to the CHA. And in this case, you can see here the error. Oh, sorry. This is the TFA, not the CHA. And the main problem here was that the TFA had wrong permissions, and it had a bug. So we actually had to remove the TFA from the previous version of the grid infrastructure with this command. And my main recommendation is that the TFA, you install it outside of the grid infrastructure. Never allow it to be within the grid infrastructure. I've seen a lot of issues that if you have the TFA within the grid infrastructure, it's going to be causing a lot of issues. Now this is the one with the CHA. So the second error that we faced was that when we were running the upgrade of the grid infrastructure, it failed right here, right? And as you can see, it was the CHA-CTL query model that it was trying to run during the root upgrade.sh. In here, how we fixed it was that we stopped the service CHA, we removed it, and we ran another status, and we were okay. This one took about 60 minutes for this service to be removed. So don't get scared if you see this one take a lot of time. The next issue that we faced was that after when we were doing the upgrade, the CRS was showing that the database was down, but as you can see here, the database was up and running. So in the last restart and the last state change, these two, as you can see, have different timings. Whatever we did, we shut down the CRS, we brought it up, and it was still showing down, but it was actually up and running. What we found was that there was a socket file that it changed ownership, and another one that had been removed by the system administrator. So what we did was we cleaned up the socket files right here. We went to vartemp.oracle and we removed all of the socket files and we restarted the CRS. Once we did this, all of the grid infrastructure was matching now to the actual status of the database. Another issue that we faced was when we were doing the grid setup, it left the CRS, it failed and it left the CRS in status upgrade final. And whatever we did, it still kept failing with this right here. So the active version that it was showing was upgrade final. We were still able to run because it had finished, but the CRS state was not in a normal state. What we found was that the management database was the one that was causing all of the issues. So what we did was remove the management database, remove the servers, the remote host server for the management DB. We removed all of the management DB files, this with an ASM command, and we recreated the management DB with this utility. Once we did that, we reran grid setup, and we were able to bring up our grid infrastructure correctly. Now, this is the same issue, and the main problem was that in this document right here from Moss was that it's telling you to run this command with these two options right here. And in reality, this documentation is incorrect. You need to run this without these two options. So this is a very high recommendation of not following whatever it is in this MOS document when you run the grid setup. Just run it like this right here. So now we were able to upgrade the grid infrastructure, and this is one of the issues that we faced in the database upgrade. So this was failing with this error right here. And what we found was that we have to apply patch to 29.33.91.55 to the 18C Oracle home, and then retry the upgrade. So we applied this patch, and we were able to move forward with this. The next issue that we faced, it's a very stupid or very dumb error because we had XDB installed in the database, and it was failing in the recompilation of these views. So we faced this error, and if you search this, you won't find any information for this error. But the way that we fixed it was that we need to make sure that the schemas have enough space for it to grow during the upgrade. So we did an alter and add data file or expand and allow it to have enough quota for the system schemas to grow, and we were able to bypass this error. The next error that we faced was that the database was upgraded, but we were not able to open our data or our transparent data encryption wallet. So what we noticed was that the password file was created without the 12C compatibility, which is this parameter right here. So the way we did it was we moved the .sso file, we recreated it, and once we did this, we were able to bypass this. Now, very important when you're recreating your .sso, never remove the P12, because this is the master key of your data encryption. So if you remove this, you're basically going to have data loss. So be very sure that you never remove that file. So to sum it up, basically do not make any unsupported configuration changes. Reduce rolling patching disk failures with DataGuard. Resist, again, customization. That's our very common errors that we have when we are doing an Exadata upgrade. It's very easy to do and install custom RPMs to our Exadata, but we tend to forget which were the RPMs that we installed and at that point in time, and it will cause us a lot of issues. Always use Exacheck before doing all of your upgrades and updates. So, and verify which software is certified with the Exadata. So make sure that all of that is followed, and I can basically guarantee that you're going to have a smooth patching and upgrade experience. Thank you very much.